On this first one, I chose a reaction we looked at before when trying to figure out, does copper dissolve in hydrochloric acid? So once again, copper oxidizing with hydrochloric acid, that would mean that the hydrogen ion is reacting to turn into hydrogen gas, and the copper is turning into copper plus 2. Well, for our reactions that actually occur, and I have the same mistake I had previously, so a little copying and pasting will clean that up. Copper is favorable to be reduced, which means it's unfavorable to be oxidized. The hydrogen reaction is what we define as 0 in either direction. But if I'm thinking of this as my cathode and forcing that to be my anode, the voltage does come out negative. So we've calculated that before, negative 0.34 volts. Well, what does that translate to in terms of delta G and in terms of K? Within this, we see it here, but we can also balance it. We have the negative sign. We have two electrons reacting. We've got Faraday's constant, and we have a negative. A negative and a negative gives us a positive, 65,600 joules or 65.6 kilojoules. A fairly measurable or significant large value there. In terms of our K, we're just plugging those numbers in up here, making sure we're using temperature in Kelvin, the right value for R, and then our G is still in joules. So we take that and we get a small value of K. This is not going to occur in a 1 molar solution. Our reactants will be hugely favored compared to our products. Here we are given a K. What do we know about this? As a general statement, we can do this right here. So K is greater than 1. That means a positive cell potential and a negative delta G. We could specifically calculate this. When I know K, I plug in all these numbers, I get my delta G. It is negative 17.6 kilojoules per mole. The struggle down here, and kind of did it intentionally, but kind of slipped up a little bit, is that if I wanted to know my exact cell potential, I need to know how many electrons are being exchanged. So we would need to know what this reaction is. We could calculate per each electron what it is, but it makes a lot more sense just to leave it with what we know. We don't know the number of electrons. We do know that it'll be a positive cell potential. And because it is joules per electron, that number of electrons is important as I get to my voltage.